All right, let's look at the homework 9.3, problem number 8. All right, so we have an exponential distribution function or density function, and the mean is 6 years. All right, so let's see. So we know that f of, in this case, t, so f of t is going to be equal to some number a times e to the negative at. So that was the general form, right? So let's find the mean of this guy, right? All right. So the mean is going to be, so it's expected value. All right. So this is going to be maybe I'll call this guy mu. All right. So here, all right. So mu is equal to. So we need to integrate from 0 to infinity. Right, a is just a number, so I'll kick it out. And so it's going to be x times e to the negative at. All right, actually, let's see. I actually changed my mind here. All right, I'm going to actually leave a inside. Right, leave a inside e to the negative at. Right, dt. Right, so this will give you a mean, so it's going to be 6, right? So I'm going to do integration by parts. So I'm going to take the derivative of that and take the antiderivative of that. So it's going to be, let's see, e to the at divided by negative a. So it's going to be a cancel out, so it's going to be just the negative e to the at, right? So by integration by parts, we're going to get here x times, actually it's going to be a negative x times e to the, sorry, I forgot the negative sign there, negative at. And then you're going from 0 to infinity, right? Then minus integral from 0 to infinity. Right, so it's going to be, there's a negative sign, so I'm going to turn it into a positive sign. Then you have e to the negative at with respect to t, right? Here, so e to the negative at, so if you plug in infinity, so e to the negative infinity, it's going to go to 0. So if you plug in infinity, it's going to be 0. If you plug in 0, it's going to be 0. So it's kind of convenient that this is actually, it's going to be 0. So it goes away, right? Then if you integrate the integral there, so it's going to be e to the negative at over negative a. Then we're going to go from 0 to infinity. So we have to use a limit too, but I'm going to just go ahead and do it this way. All right? So if you plug in infinity here, this guy goes to 0. So you're going to actually get 0 minus, right? There's a negative sign, so it's going to be plus. So if you plug in 0 here, e to the 0 is 1. So you have a 1 over a, right? So the mean is actually simply 1 over a. All right, so since mean is 1 over a, but we know that this is equal to 6, right? So we know that a is, just to take the reciprocal of both sides, a is 1 over 6, right? So this is going to be 1 over 6 e to the negative t over 6, all right? So let's type it in. All right, so we're going to get 1 over 6, right? E to the negative t over 6. All right, so I'm going to actually get rid of that parenthesis there. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, and let's do part B. All right, so find the probability that the printer will fail in more than 1 year, but less than 5 years. All right, so I'm going to do a GeoGebra here. So I'm going to define the probability density function, f of x to be, all right, so it's going to be 1 over 6, all right? then times exponential function, and you have a negative x over 6. Make sure to use x instead of t, right? So hit enter. Right, so you have exponential function. Then all you have to do is integrate it. All right, so it's going to be more than 1 hour and 1 year, and less than 5 years. Did they say? Let's see, 5 years. Okay, so it's going to be between 0 and 1. Actually, it's already. So this is the result. And what's the precision? 4 decimal places. So I have to change it to 4 decimal places, right? So it's 0.4119, right? We get 0.4119, right? Let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly as well. All right, that's it. I hope that this was clear.